This assessment asks us to predict the product when an ester is used in an alkylation reaction. The reaction will start the same way. LDA is going to remove the acidic alpha proton from the ester, the product of which will once again be an enolate. We can draw that enolate in either of two ways. We can show it as just the negative charge on carbon, or we can show its resonance structure where the negative charge is on oxygen. Regardless of which one we use, when we react this with a primary alkyl halide, we're going to do an SN2 reaction. Shown using the resonance structure on the left, it would end up looking like this, where the negatively charged carbon donates a pair of electrons to this carbon, kicking out the chloride. Alternatively, we could use the arrows from the other resonance structure, moving these electrons down, pushing out the pi electrons to attack at the same position, once again, kicking out the chloride. Regardless of how we do this, we'll end up with the same product, that product being this. As always, we can check our answer by making sure that our carbons are numbered correctly, or that we can number our carbons to make sure that we have everything present. So if this is, the chain is 1 through 5, we have 1, 2, 3, 4, 5. Our mechanism suggests that we're going to add an ethyl group to carbon 4. We have in fact added an ethyl group to carbon 4. We could label those 6 and 7, 6 and 7. The numbers match, therefore the product must be correct.